Hi students, welcome to my YouTube channel SADHIK Physics. So we are already dealing with a ray optics. Almost we completed 7 videos which are concepts and problems, right? So one more important topic no in ray optics no and with applications. So we'll discuss lens maker formula, right? Lens maker formula and its applications now, right? So let us see. So what is meant by lens maker formula? So lens maker formula, right? So we already studied the refraction through the spherical surfaces no or curved surfaces no. So from that only we can derive it no. Therefore suppose this is one lens is there. So this is one lens is there. So therefore this side one curvature is there. Therefore if I go into extend it no, therefore it is having some R1 will be your radius of curvature no. Suppose this one more curvature is there. So therefore here we are going to take it as like a, so another one more curvature second surface no. So this radius no, we can take it as radius of curvature of this one. Clear? And this is made up of with a refractive index, suppose it will be N2, and this is kept in a one medium, suppose N1, and is also coming out from this one now N1 now. So therefore here we can write the focal length of this lens no. Therefore how to write the focal length of 1 by f, it will be equal to, so refractive index of this lens with respect to air, this is if you are taken as like air. So therefore refractive index of the glass with respect to air, so therefore minus 1 into 1 by R1 minus 1 by R2. So this 1 by f we can write it like a power of the focal length now, right? So power of the power of the lens no, therefore is equals to 1 by f is equals to refractive index of the glass, that means this is made up of with one glass and kept in the air no, right? So if you are taking for air, minus 1 into 1 by R1 minus 1 by R2. So this is nothing but our lens maker formula. So to use this formula compulsory you have to follow the sign conventions again now. What is the sign conventions now? This is your optic center. So this side distance is to be taken as positive, this side distance is to be taken as negative. So why? Because light rays are coming from this side no. If you are assuming that light rays are coming from this side you have to take it as like a positive, this side you have to take it as like a negative. Clear? So that means here R1 is there. So therefore refractive R1 to be taken as positive, R2 to be taken as negative. Clear? So this is only we will call it as like a lens maker formula. Clear? Now also we will see the combination of the lenses and so therefore we will see some of the applications no. Now we will go for one application no. See here. Suppose this is one biconvex lens, right, or double convex lens. So double convex lens. So assuming that this side radius of curvature is R1 is nothing but a R and R2 is also nothing but a R, and it is made up of with the refractive index is N kept in the air. Clear? So we want to calculate focal length of this lens no. How to write it now? Therefore 1 by f it will be equal to refractive index minus 1 into, so this side R1, therefore you can take it as R1 is this side. So therefore it is taken as positive 1 by R. R2 is taken as negative, therefore minus of minus 1 by R. So therefore here you can write down 1 by f is equals to n minus 1 into 2 by R. Clear? So focal length of this biconvex you can write down R by 2 of n minus 1. This is nothing but a refractive index, absolute refractive index of this one. Clear? So however refractive index is greater than 1 no. So therefore this it will be equal to like a positive. So positive means focal length of this one is positive. So this is double convex and double concave. So this is your biconcave, double R by this all are, so same only. Concave, this is nothing but a R1 is equals to R, R2 is equals to R. So therefore what will be the focal length of this one? Same only. So the focal length of this one it will be the same, but it will be the minus R by 2 of n minus 1. So this is nothing but a biconcave lens, its focal length formula. Clear? Now try to will find it. So focal length of the plano-convex, so that you will conclude here one important observation. No, so we'll go for plano-convex. Let us take this one. Plano-convex. Plano means one plane here, no, and convex means here like this. Suppose here. Clear? So therefore here what you can write it now, R1 will be equal to this is a plane, no, where it will be go, what is the radius of curvature? It will be at infinity. You understand? No, plane we cannot make it like a radius, no, radius it is goes on to infinity. So R2 will be equal to R, will apply the lens maker formula. 1 by f is nothing but n minus 1 into 1 by R1 is infinity. So minus 1 by R2 is nothing but a minus R. Clear? 1 by infinity is 0. So therefore, so focal length it will be equal to R by, so therefore n minus 1. So that means you try to observe it here, no, therefore whose focal length is more, no, therefore focal length of this one it will be larger. Why? Because R by n minus 1. Focal length of biconvex is how much now? R by 2 of n minus 1, exactly half of this. So that means what will happen now? So this is having lesser focal length, this is having greater focal length. Power what will be inversely proportional, no? Power of this one is less, power of this one is greater. You understand, no? That means, so by using this concept now, therefore what we can write it now, see here. These type of concepts now frequently asked in the JEE mains and most of the examinations, no? See here. Suppose this is one lens is there, this is one lens, convex lens, whose focal length is f and power is p. Now what I am going to do, therefore I am going to divide this one into two parts here now. This is two parts. So I am going to take it as like a one part here, no, this is one part, right? Any one more part also we can take it here, no. Therefore here these are the, I am making like a two parts. What I am doing now, I am dividing like this, perpendicular to this your principal axis now. Now what happened now, focal length is what is happening now, when you are dividing like this, so focal length will be becoming increase. So therefore focal length will become like a 2 times of f. So therefore focal length will become like a 2f. But what is going to decrease now? Power will be decreased, power will become like a half, power will become like a half. So that means if you divide vertically like this now, therefore the focal length will become like a double time and the power will become like a half. Now you can get one more doubt now, sir, I don't want to divide like that, I want to divide like this. See here. So this is your focal length and power is p. Suppose if you are going to divide this one into two parts like this, I am going to take it one part here, no, therefore another one more part I am going to take it here like this. I am going to divide upper part and lower part. See, therefore suppose light rays are coming here now, so therefore it is undergoing like a, so bending, it is because of due to at this time, at this point the property only. So this part now does not show any effect on to this one now. Therefore here if a light rays are coming, same amount of converging will take place, no. So therefore focal length and focal length will be the same and power also it will become like a, remains it will be the same. You understand, no? Suppose if you take, if you remove this part, no, therefore this much part of the light is not coming, no, therefore intensity of the image is going to decrease. Intensity of the image formation, no, it will be decreased. Apart from that, there is no change in the power, there is no change in the focal length. Clear? So be careful now. Therefore, how we are, if we are dividing the lens now in two parts, that means along this vertical part now and along the horizontal part. So if you are doing, if you are dividing like this, making like a plano of this one, no, therefore focal length will become double time and power will become like a half, right? So not only this convex, no, concave also it will be that become same, no. So if you take it as plano concave, suppose if you take it as one plano concave, so this is one plano concave, therefore what will be the focal length of this one, no? Focal length it will become like a, so minus r by n minus 1. So therefore here the focal length of this one. Clear? So most of the times, no, so try to remember these formulas. If you don't remember also no problem, just I will see the only lens maker formula. But here the division of the lens, no, so that is most important in this scenario. Clear? So now what you are going to do now, therefore suppose now the lens, what you are going to do, we are going to immerse inside the one liquid. What is going to happen now? Lens we are going to keep inside a liquid. Also I will tell one shortcut here, no, right? So very good information you are going to get it here, no. So let us see what is that, no. So here suppose, let us see here, no. Okay. Now suppose here this is a lens is there, no, this is a lens, clear. So it is made up of refractive index of the glass with respect to air, and this is kept in the air, no. So what will be the focal length of this one, no, it is f. What you can write it now, f is equals to refractive index of the glass with respect to air minus 1 into 1 by r1 minus 1 by r2, this is in the air. Clear? So now what I am going to do now, I am not going to change any radius of curvature, no, therefore I am going to keep it inside some liquid, no, we do not know what is that liquid. So this is in the air. Now we are going to keep it inside the liquid, no, whose refractive index of the liquid is NL if A. Clear? Now what you can write it now, focal length, sorry, this is 1 by f, no, 1 by f in liquid, it will be equal to refractive index of the glass with respect to liquid minus 1 into 1 by r1 minus 1 by r2. So this is not going to change, no, therefore this will get cancelled out, no. Therefore here what I will get it now, focal length in the liquid by focal length in the air. So what I can write it now, it will be 1 by, it is however inversely proportional, no, therefore here refractive index of the glass with respect to air minus 1 by refractive index of the glass with respect to liquid minus 1. So this is here the ratio, still some more modification, no. So here this is relative refractive index, no. I taught you this one in the refraction video, so please go through it, no. Therefore focal length in the liquid, it will be equal to refractive index of the glass with respect to air minus 1, so by, so refractive index of the glass, so therefore here what you can write now, refractive index of the glass with respect to liquid. Therefore refractive index of the glass with respect to air by refractive index of the liquid with respect to air minus 1 into focal length in the air. Right. So therefore this is the formula, this is with respect to air, this is also with respect to air. Now what we will see, no, we will see 3 different scenarios, no, one scenario. So remember this formula, now we will see. So first condition, what is the first condition now? Suppose here refractive index of the glass is greater than refractive index of the liquid. Suppose it is greater. Now what will happen now? So therefore focal length of this liquid in lens, no, so refractive index of the glass minus 1 by refractive index of the glass by refractive index of the liquid minus 1 into FA. Clear? So that means if this is greater, which is greater now, refractive index of the glass with respect to air is greater, so take this ratio, so therefore Ng by NL will be greater than 1. Greater than 1 is not too much greater, no, therefore it will be 1.2, 1.3 like that, no. Therefore it is greater means minus subtracted by minus 1, no, so you will get it as 0.3, 0.2, 0.7, something like that you will get it now. That means, so this is divided by the smaller number, so anything divided by the smaller number, that you will get it as larger now, and there is no change in the negative of this one, no. So therefore focal length of the lens in the liquid will be greater than focal length in the air, so without changing in nature, no change in nature. Means what? That means if you are immersing the convex lens, so it will be act like a convex lens only, like converging lens only, right? So if you are immersing the diverging lens, no, so there is, it will behave like a diverging lens, but focal length will be larger. Clear? So no change in the nature. That means what will happen now? Suppose this one lens is there, no, so here we are going to place inside the liquid, no, there is a one liquid. What is the condition? It is then there, no, refractive index of the this is your glass, this is your liquid. So, but this glass is having more, so refractive index no, therefore what will happen now, therefore focal length of this one no, it will be increases. So, focal length it will be increases, clear? Focal length it will be increases. Here one small application we can do it no. Refract, if you take this as your water, water means you know that no 4 by 3. So, glass means nothing but a 3 by 2, that is nothing but a 1.5. 1.5 is greater, this is nothing but a 1.33. So, that means if a lens is made up of a glass no and immersed inside the water no, just to substitute in this one no, you will get your formula, right. So, what are the things? Just try to substitute it. I will tell you one small shortcut no, but refractive index of the water should be 4 by 3 and glass should be only 3 by 2. If this is given no, then you can calculate the focal length of this lens no, focal length of the lens in the liquid. So, liquid, that is liquid is nothing but a water, nothing but a water, it will be equal to 4 times of your focal length in the air, that is all. No need to think anything, just remember this one no, but condition provided that it should be made up of 1.5 and it should be immersed inside the water no of this refractive index, then you can use it no. Suppose 20 focal length is there no, is immersed inside the water, so 20 into 4 80 it will be your answer, clear. So, this is one of the shortcut one no, but applied with a lot of conditions no, clear, you understand no. So, keep in mind. So, no need to solve anything no, just 4 times. How I got sir this one no, substitute these values no, you will get your answer on this, clear. Next, suppose second situation no, suppose refractive index of the glass is equal to refractive index of the liquid. Now, what will happen now, therefore, so focal length inside the liquid it will be equal to Ng minus 1 by Ng, so by NL minus 1, so into Fa. So, these both are equal, this will become like a 1. So, what will happen now, therefore, focal length of the lens, so will become like a infinity. So, infinity means there is no converging onto this one no, there is no diverging or anything no, therefore, looks like lens is disappeared. Lens is disappeared. Suppose this is one lens is there. Okay. So, that means here when it is refractive index of the liquid and refractive index of this one now, both are same. Therefore, if a light rays are coming, there is no converging, there is no diverging no, light rays it will go like this only. Therefore, so in this way the lens which is placed inside this one now, it looks like a disappeared, we cannot see the lenses now. So, this will be done by the magicians no, where they will make it like it is lens is disappeared. Why? Because their refractive indices are both are same, clear. Now, more important scenario, therefore, third condition. What is the third condition now? Focal length of the refractive index of the glass is less than refractive index of the liquid. So, what will happen now? Therefore, focal length in the lens in liquid, therefore, Ng minus 1 by Ng by NL minus 1 into Fa, clear. So, what will happen now here? So, here this ratio, therefore, Ng by NL will be less than 1, will be less than 1. Why? Because Ng is smaller, NL is greater. So, this is less than 1 means 0.7, 0.8, 0.9 like that it will be there. So, minus 1 means 1 is greater. So, therefore, so if you subtract it no, you will get smaller number, but with a negative one no, therefore, again divided of this one no, you will get larger. Focal length of the lens will become greater than, so focal length of this one no, and becomes it is negative of this one no. Therefore, so negative it is changed no, negative changed means what will happen now, focal length is increased, but negative it is changed no, that means if your positive focal length is immersed no, negative focal length it will be developed no. Therefore, so nature also changes. That means convex will behave like a concave, concave will behave like a convex. You understand no? So, therefore, suppose this is one lens is there. what happens now? Suppose this is one liquid is there. So, whose refractive index of the liquid is greater than refractive index of the glass. Now, however, if it is like a parallel beam of light rays are coming and falling on this one now, this parallel beam of light rays will get diverged here now. So, that means what will happen now? This convex lens behaving like a concave lens. You understand? No? Nature is also changed. So, why this is changed now? Because of due to outside refractive index is greater now. Suppose here concave lens is placed now. Concave lens is placed and there is a one liquid is kept now. So, therefore, here light rays are coming and falling now. So, what will happen now? It will act like a converging lens. So, concave will behave like a convex. So, sometimes the statements will be given in a competitive examination now. Will convex lens is always like a converging lens? Is it true or false? So, therefore, it is not true. Why? Because convex lens will be act like a converging lens, but if it is outside medium is lesser than the refractive index of that one now. But outside refractive index is greater, so than your glass no, then it will behave like a concave lens. Clear? So, that is why sometimes the questions will come no, there is a water is there. So, there is a water is there. So, in the water there is a one air bubble is formed. This is one air bubble is formed. Inside the water there is a air bubble is formed. How it is going to behave it now, right? So, the air bubble which is formed inside the water, so how it is going to behave now? Refractive index of this one now, refractive index of this water and this refractive index of the air. So, refractive index of the water will be greater than refractive index of your air. So, therefore, here this is a rarer medium, even though converging surfaces are there, does not matter now, this will behave like a concave lens. Clear? So, concave lens it is going to behave now, even though it is in convex in surface of this one, no, but refractive index is lesser than this one. No? So, then it will behave like a concave lens. Therefore, air bubble inside the water. Clear? So, it will behave like a concave lens. Clear? So, now let us see one more thing now. So, combination of the lenses, very important, combination of lenses. So, if the lenses are kept separate, no, I already dealt with a previous video how to solve the problems, no. If one lens is there, kept other lens, no, therefore we solved it, no. But here in most of the cameras, right, like a zooming lens, no. So, therefore, here the lenses will be in combined one, no. Therefore, this is one lens is there. So, another one more lens it will be there. So, like this. So, one more lens it will be there, or maybe one more lens it will be there like this. So, therefore, here these are the lenses no, which are combined here now. Therefore, if you want to calculate the focal length and all these no, combinations, no. So, what you have to do it now, just a simple thing. So, this is one lens, this is second lens, this is third lens. Power of the combination will be equal to power 1 plus power 2 plus power 3, so on. How many combinations are there? But to use this one, no, compulsory follow the sign conventions. One is convex lens. So, another one is concave lens. Convex lens power is positive, concave lens power is negative, right. So, if you write it now, therefore, 1 by f it will be equal to 1 by f1 plus 1 by f2 plus 1 by f3, so on like this. Clear? So, we know the magnification already I told you, magnification of the combined lenses, no. So, it is m1 into m2 into m3 into so on. These are the magnification factors. Clear? So, therefore, you can have the combinations of this. So, by using these concepts, no, you can able to deal the questions now. Clear? We will see some questions also related to this. This is here one important for most of the competitive examinations now. Clear? Now we'll see. Now we'll see. So mirroring of the lenses, no. So therefore here mirroring of the lens. That means there is a one lens is there. This is one lens is there. So suppose this one side, therefore there is a silver coating is done. This one side silver coating is done now. Therefore, so instead of this one now silvering of lenses, no. Therefore here, so we can write down silvering of lens. Clear? Now what will happen now once it is coated like this, no. Therefore what will happen now, this lens behave like a concave mirror. Why? Suppose there is a one object is there, no. Suppose here this one object, light rays are coming from here, no. Then it will undergo like a refraction. So then it will undergo like a reflection here, no. This reflected light ray, so will combine again one more refraction, no. So therefore here this is your object, no. This is your image. In this way, two times the refraction is taken place, no. One time there is a reflection will be taken place now. So that means what you can write it now here. So again any combinations, therefore one lens you take it now, one mirror, therefore this you can take it as like a one lens plus one mirror. So one mirror. So therefore here what is going to happen now, the power of this one, no? Therefore power of the combination, therefore you can take the power of this one, no? P1 power of the lens plus power of the mirror plus again therefore power of the lens. Therefore power you can write down two times of your power of the lens plus power of the mirror. You can use this formula. So then you can solve it, no. R1 by F it will be equal to, so 2 by therefore FL plus 1 by FM will be your formula. Clear? So how to calculate the power? Therefore focal length you can write down. So power of the lens you know it, no, how to do it, no. So here power of the lenses, no, you know it, no. Power of the mirror, how to calculate now? Power of the mirror is nothing but 1 by Fm. So will be the power of your mirror now. Power of the lens already we know it, no. You can calculate it now. Clear? So you can use this formula to calculate the power, but to use this one, no, compulsory follow the sign conventions now. Clear? So now therefore we will see some questions, no, so that you can understand very clearly. So let us see here, no. This is one question, no. I think if it is visible is okay. So if not, just to listen. So it is, this is the lens, no, is made up of with the refractive index is 1.5. So it is kept in the air. So this side it is there, R in this one, no. So you can write down 1 by is asking find out the focal length, 1 by F it will be equal to, see n minus 1, therefore kept in the air only. So therefore 1.5 minus 1 into 1 by R1, this is R1 20 centimeter 20 minus of minus plus 1 by 30. Clear? So lens maker formula we can use it now. 1 by F is equals to 0.5 means 1 by 2 into, so this I can make it like a multiply 3 multiply 2. So therefore 60, therefore 5 by 60. Clear? So focal length it will be equal to 120 divided by 5. So 5 ones are 524. So 24 right centimeters will be the focal length of this. Clear? Sometimes by giving like this, no, they may kept one object and you can ask, they can calculate the, so everything, or they may ask you what will be the power of the combination. Power it will be equal to, so that is nothing but a, you can write down 100 by therefore 24. So diopter, so will be your focal length of this. Clear? Clear? Now let us go for one more question now. Yeah, it is a similar type of question only. So therefore here it will be the same, but you will get it as negative of this, therefore 1 by f. So refractive index is how much now? 1.5 minus 1 into 1 by, this is R1, this side it is there, no, it is minus 20. So this side it will be there, so therefore it will be minus of that plus, therefore minus 1 by 30. Clear? So this is nothing but a 1 by 2. So this how much now? It will be, so again multiply 3, multiply 2, minus 5 by 60. So 1 by f. So therefore here, so f is equals to minus, so 120 divided by 5, so minus 24 centimeter will be your focal length. Clear? Simple questions, no? Now we'll go for another question. Okay. So convex, so right, concave like that, no? So therefore this is one different type of one, no? Therefore we can see refractive, of the lens is 2, but this side it is kept, it is 4 by 3. Clear? So not in 1. So that means what you can write in 1 by f, it will be equal to refractive index of the glass with respect to the medium. Clear? So therefore what will be the refractive index of the glass with respect to, so this glass with respect to medium minus 1 into 1 by R1 minus 1 by R2. So what I can write it now? 1 by f is equals to refractive index of the glass by refractive index of the medium with respect to here minus 1 into 1 by R1 minus 1 by R2. Clear? So 1 by f, it will be equal to refractive index of the glass. Glass means it is lens, no? So it is given as 2 by this one now how much, no? 4 by 3. 4 by 3 means into 3 minus 1. So into 1 by R1. R1 is curvature toward this side, no? Therefore 20 minus 1 by R2 also it is toward this side, 1 by 30. Clear? So how much it will be now? 2 ones are 2s are, therefore, so 3 by 2 minus 1 means, so 1 by 2 into, again multiply 3, again multiply 2, 3 minus 2 is 1 by 60. So 1 by f. Therefore f is equals to 120 centimeter, no, will be your focal length. Clear? Right? So now let us understood, no? I am can go through it. So if the focal length of the convex lens of the, right, it is given as refractive index of the lens, it will be equal to 3 by 2. Focal length in the air, it will be about 20 centimeter. Find out the focal length of the same lens in the water, the same. So refractive index of the water is 4 by 3. I already told focal length of the in water, so it will be equal to 4 times of your focal length in the air. 4 into 20, that is nothing but 80 centimeter. So how, sir? Substitute the formula, you can get your answer. Very simple. Clear? So find out the optical power. We want to calculate the power of this. Okay, already we discussed this one, no? This is everything. So I think the values are also same, therefore power it is given, no? So we know it already, so therefore we can neglect this question. So this is already the same, okay? So then not required anything. Clear? Right. So in terms of R we can write down. Okay, just this is in terms of R, no, 10 and 30 it is given. Okay. Now it is in terms of R, therefore first of all focal length of this one is how much, no? It will be R by of 2 of n minus 1, this is minus. So power it will be equal to 1 by focal length, no? Therefore 2 of n minus 1 by R minus. This is your power of this one, no? Therefore it is minus. Clear? This is the power of this lens, no? So we can write it. Now equiconvex, same thing. So therefore power, focal length it will be equal to R by 2 of n minus 1 power it will be equal to 1 by f. So 2 of n minus 1 by r. This is plus. Clear? Now, power of the convex lens in the air is 10 diopter. Now it is immersed inside the water. No, find out the power of the lens in the water. Okay, very simple one. No, see here. Therefore, we know that. So power focal length in the lens in the liquid. No, it will be equal to 4 times of your focal length in the air. So focal length in the liquid we can write down 1 by power of this and 1 by power in the lens. No, I mean of the lens in the liquid 4 into 1 by focal length power in the air. So power inside the liquid, no, therefore you can write down power in the air by 4. So power in the air is how much? No, 10 diopter divided by 4. So therefore it is nothing but a 2.5 diopter. Power will be reduced. Why? Focal length will be increased. Clear? So simple questions, no? If the focal length of the convex lens, yeah, same question, no? Why these questions are added? Okay, just let us see, no? Now, okay, find out the power of the equivalent and focal length of the equivalent. Let us see. So these are the two lenses are there kept in the some contact. No, two lenses are in contact here. Clear? Now, so now let us see. Okay, first let us calculate the focal length of this this one convex lens and focal length of this one. How to calculate the focal length of this? Focal length of this one is nothing but a r by 2 minus 1. Therefore, this is 20 by 2 of, therefore, n minus 1, therefore 3 by 2 minus 1. So 1 by 2, therefore focal length of the convex lens it is about 20 centimeter of this one. And focal length of this one it will be the different here, no? Why? Because here this side 30, this side is 20. Therefore, so I will find out the focal length of this second lens, no? So 1 by f it will be equal to refractive index is 2 minus 1 into 1 by, so this side, so negative, therefore minus 20 minus this side positive 1 by 30. Clear? So 1 by f is equals to 1 into, so therefore here minus, therefore 5 by 60. So f is equals to 60 by 5, therefore 1 is minus 1, 12 minus 12 centimeter. Clear? Or you can calculate the power here, no? Power also you can calculate, or focal length you can calculate 1 by f equivalent, no? That is nothing but 1 by f1 plus 1 by f2. 1 by f1 is how much now? 1 by f1 1 by 20 minus 1 by 12. So you can take it as LCM, no? 20 and 12, 4 is 5, 3. So 4 and 4 5 is 20 means multiply with 3. So 4 3 is multiply with 5. So therefore 60 it will happen, no? This is 60. So 3 minus 5 minus 2, 1 by f equivalent. Therefore, so f equivalent you can write down, therefore here 60 by 2, therefore minus 30 centimeter. So this combination will behave like a concave lens, right? If you are calculating the power, so power of equivalent, no? So it is 100 divided by f. So therefore it is minus 30. So what you can write it now? 3.3 minus 3.33 diopter. This is your power equivalent. This is nothing but a focal length equivalent now. Clear? Right? So like this, the combination of the lenses, no, you can do it. Clear? Now suppose here this is one question, no? So lens of power 3D and 5 minus 5D are combined to form like a compound lens. An object is placed at a distance of 15 centimeter from the lens. Now find the position of the image. Yes. So power of the combination. No? Therefore here power is equal to, so 3 diopter minus 5. Therefore here it will be minus 2 diopter. That means it's concave lens. So what is the focal length of this one now? Therefore it will be 100 by f in centimeters. So it will be equal to minus 2. Clear? So therefore focal length in centimeters, it will be equal to minus 50 centimeter. So where the object is kept now, no need to calculate anything now. Object is kept at 50 centimeter. Okay, at focus it is kept here now. Clear? So if it is kept at the focus now, therefore now where the image will be created, let us see, apply the formula. 1 by lens is equals to 1 by v minus 1 by u, that implies minus 1 by 50. It will be equal to, clear? So 1 by v, so minus of minus plus 1 by 50. So 1 by v is equals to minus 2 by 50. So v is equals to 25 centimeter. Minus means on the same side. So therefore image distance is at 25 centimeter. Clear? Right? So now let us see one more question. Right, two identical glass refractive index equiconvex lens of focal length f kept in contact, the space between them now filled with a liquid. Okay, so this is one of your competitive examination question. No, so this is one lens is there, this is one lens and another one more lens is there. So same identical lenses, no, identical lenses. Therefore here there is a liquid is kept in between these one. No? Right. So now we want to calculate the focal length of this combination. No? Therefore here this is made up of with the refractive index is 3 by 2, this is refractive index is 4 by 3. So first he did not give any radius of curvature. No? Power of this one, no? Focal length of this one is f is given. No? This is f and this focal length is also f. This focal length I don't know, water lens you have to find it. No? So water lens focal length, no, for this one if you want to calculate, you should calculate the radius of curvature of this. So what is the radius of curvature? Focal length, it will be equal to r by 2 of n minus 1, r by 2 of n value is how much now? 3 by 2 minus 1, 1 by 2, 1 by 2 cancel. So that implies focal length, it will be equal to the radius of curvature. Clear? Then we can calculate the focal length of this water lens, no? Focal length of this liquid lens, no, it will be equal to r by minus r by 2 of n minus 1 means 4 by 3 minus 1. How much it will be? So therefore here 1 by 3, so minus 3 r by 2, so will be the focal length of this one. So therefore you can write down 1 by f, it will be equal to 1 by f1 plus 1 lens, so 1 by fl plus 1 by f1. So you know that therefore this focal length of this one now is both are same, therefore it will be nothing but 2 by f. So this it will be r is there, no, minus 3 by 2 into r value is nothing but f, r and f. Clear? So therefore it will be minus 2 by 3f. Clear? 1 by fl. So here I can rewrite it as 2 by f, I can take it common, 1 minus 1 by 3. So therefore here you can write down, so 3 minus 1, 2, 2 by 3, therefore it is 4 by 3f, 1 by f, no. So f is equals to 3f by 4 will be the focal length of this combination. Clear? So be careful, no. So this type of questions. Clear? Now we will see. We will see. Okay. A convex lens of focal length 25 centimeter, concave lens of focal length 20 centimeter are mount coaxially and separated by distance d. If the power of the combination is 0, then d is equals to. Right? For this type of questions, no, we should have one formula here. So therefore here this is your this is one lens, no, another one more lens, no, separated by distance is d. Therefore here having the focal length is f1, f2. So we can write down, so power of the combination, power 1 plus power 2 minus d into p1 p2. So this it will be the power or focal length, no, we can write down 1 by f, it will be equal to, so 1 by f1 plus 1 by f2 minus d by f1 f2. So this is the formula. So you can use it, right. So can go through it, no. Power of the combination, first of all let us calculate the first power of this first one. How much, no? Power of the one, it will be equal to 100 by 25, that is nothing but a 4 diopter. This is concave lens, this is not in this nature, no, therefore this is right. So therefore that implies power is equals to, so therefore 100 by f is in 20, therefore minus 5 diopter. Clear? So power of the combination, it will be equal to 0. So power equivalent, it is equal to 0. 0 is equals to power 1, it is nothing but a 4 minus 5 minus d into 4 into 5. So that implies, therefore this is minus of minus, this will become like a plus. This is minus 1 taken here, no, 1 is equals to 20 into d, therefore d is equals to 1 by 20. Therefore it is in meters, no, therefore here d is in centimeters, means 100 by 20, so therefore it will be 5 centimeters. So this it will be your answer. Right, let us discuss this question, no. So therefore I think we did this type of, no, but here extra thing is we are going to make it like a silvering of this. So these two combinations, no, I already discussed. So the focal length of this lens, no, so let us see this question, no. Here I already discussed this one, no. Focal length I got it as 30 centimeter, power I got it as 100 by 30. So let us see here, no, we will use that concept. Here focal length of this combined lens, no, I got it as, it is minus 30 centimeter. Power of the lens, no, I got it as minus 100 by, that is 100 by, so that is 30. So therefore here I will get it as minus 10 by 3 diopter. Focal length of the lens of this combined lens, no, I got it now. So now focal length of the mirror, so we can write down r by 2, so therefore 30 by 2, therefore 15 centimeter. Power of the mirror can be written as 1 by focal length in mirror, that is 100 by this one in centimeters, minus 100 by 15, no. So 5 3s are 5 20s are minus 20 by 3 diopter. So we can write down power equivalent, no, therefore 2 times of your power of the lens plus power of the mirror. Clear? So that implies 2 times of your power of the lens, no, therefore minus 10 by 3, so minus 20 by 3, so therefore here minus 20 minus 40 by 3. So power of equivalent, no, I got it as 40 by 3 diopter. Clear? Focal length in therefore in centimeters, no, right? So 1 by focal length power, it will be equal to 100 by focal length, no, 100 by therefore power equivalent, no, 40 into 3 minus, so therefore it is 2 5s minus 15 by 2 minus 7.5 centimeter. Focal length of this I got it as equivalent focal length, no, I got it as minus 7.5 centimeter. Power equivalent, no, I got it as 40 by 3 diopter. Clear? So this it will be your mirroring and your dual lens now. Clear? Now let us see one more question now. So find out the power equivalent and F equivalent of the combination now. Power equivalent, what you can write it now? This is your plano convex lens. So plano convex lens focal length, it will be equal to R by n minus 1. Power, it will be equal to, so therefore n minus 1 by R. Power of the lens. Clear? Right? So this mirror, focal length of the mirror, it will be equal to R by 2. Power of the mirror is nothing but a minus 1 by Fm. So minus 2 by R. Clear? So this is combined power, it will be equal to 2 times of your power of the lens plus power of the mirror. That implies 2 times power of the lens is n minus 1 by R minus 2 by R. So what I can write it now? Plano convex. Okay. Right. This R is toward this side, minus. This is minus or minus plus. So I will get it as plus here because this side it will be your mirror, no? Okay, this it will become plus, no? So 2n minus 2 by R plus 2 by R. This will get cancelled out, no? So power equivalent, no, we can write down 2n by R. So this is your power equivalent, no, right? Focal length of this equivalent, no. So therefore R by 2n, but it is minus. So from this one now you should understand focal length of your concave to be taken as negative, but power of concave to be taken as positive. Be careful now. So most of the students now will confuse in this. Clear? Now let us see here now one more. Same question now. Focal length of this lens, no, therefore R by n minus 1. So the mirror, focal length of the mirror, so this is your straight line, no. Focal length, it is not going to converge anywhere, no, therefore it is infinity. Clear? Why? Radius of curvature, it is at infinity. Focal length of the mirror is infinity. Power of the mirror, it will be 0. Clear? So what I can write it now? Power of the lens, power equivalent, no, this is silver coating, no. So 2 times of your power of the lens plus power of the mirror. So therefore here power of the lens is nothing but n minus 1 by R. Clear? So power equivalent, no, therefore 2 into n minus 1 by it is R. So 2n minus 2 by R will be your power equivalent. Yes, F equivalent is R by 2 of n minus 1. Clear? So let us see again. He did not give anything, no. We will consider this is n, this is having R. So we know it, no, therefore focal length of this lens, no, r by 2 of n minus 1, power of the lens is nothing but 2 of n minus 1 by r. So therefore here focal length of the mirror, so r, focal length of the mirror, so it is how much, no, r by 2, clear. So this is now it is minus power of the mirror, it will be equal to minus 1 by f, no, therefore it is 2 by r plus, clear. So therefore here power equivalent, no, 2 times of your power of the lens plus power of the mirror, 2 of n minus 1 by r plus 2 by r. So what I can write it now, 4, therefore 4n minus 4 by r plus 2 by r. Four n by r. So therefore here what you can write it now, here r is same 4 minus 4, therefore it will be minus 2 by r. So power equivalent is nothing but 4n minus 2 by r. n minus 2, clear, right. So now we'll go for one more combination, okay, right. So thank you for watching. So please subscribe to my channel, no, so that you can learn physics very easily, right. And also share these videos, no, so those who need physics classes, no. Thank you.